than 0 plus 3. Okay. So yeah, 0 is less than 3. Okay. So check, this is, what you're asking yourself now, is this true or false? Okay. This is true. 0 is indeed less than 3. Okay. So when you enter this point, or any point you want to enter, you enter this point and you simplify and you get a true statement, that means that point is part of your solution. If you got a false statement, then that point would not be part of your solution. And you don't have to test infinite points. If this point is part of your solution, then everything on this side is part of your solution. Okay. If this point was not part of your solution, then nothing on that side would be part of your solution. You'd shade the other side. Okay. So in this case, that origin, as Instinct showed you, and then proved it right here, is part of the solution. So that means this entire side of the boundary line gets shaded. Okay. So that right there just means that was our test point.
I kind of just imagine the like y line, and it says less than, so it has to equal less than that, you know?
Yeah. Sometimes, though, this expression here, though, can kind of throw things off, because it changes things when you're multiplying and adding or subtracting things to it. So it doesn't hurt to go ahead and do this just to verify. Yeah. So our step 3 is to shade the true side. Okay. So if your test point is true, then that's that you shade the side of the test point. If your test point is false, then you shade the other side. The other side will be the true side. You don't have to test a point over there. You know it's true because one side is false and one is true. So if you found the false side, the other side is true. Okay. Now if you go through the origin, just a really quick extra example. So let's say y is greater than or equal to 2x. Okay. So the system is, here's our inequality. So I would graph the related equation y equals 2x. There's no constant. That means it goes through the origin. And with a slope of 2x is up 2 over 1. My line includes or equal to, so it's going to be a solid line. There's my boundary line. And because it goes through the origin, my test point cannot be 0, 0. So maybe I'll use 1, 1. Yeah, 1, 1 is not on the line. It's close to it, but it's not on it. So I'm going to go ahead and use 1, 1. Like I said, as long as your slope isn't 1, then 1, 1 will work. If your slope is 1, then you have to choose something different. So I'm asking myself, is 1 greater than or equal to, question mark, 2 times 1? Is 1 greater than or equal to 2? True or false? Yeah, that is false. 1 is not greater than 2. So when I plugged in that test point 1, 1, I got a false statement, which means that test point is not a solution, and therefore nothing on this side is a solution. So this is the false side. That makes this the true side, the side without the test point. Make sense? Okay. So we'll finish up with practicing. So on the other side of the graphing just the lines, here we'll be graphing inequalities, which is where you graph your boundary line and then decide which side to shade. Okay. So we'll do. Okay, so this is chapter 8.7 here, the inequalities. And we'll do y is less than or equal to negative x minus 3. 2x plus 5y is greater than negative 10. Let's also do y is less than 2, and x plus 7 greater than or equal to 1. Now you notice if you have horizontal and vertical lines, you'll find a test point really isn't necessary. Because it's real straight. Without the diagonal is what can kind of throw off your perception some. But with horizontal and vertical, it's either less than or greater than. It's above or below, or it's left or right. You can do a test point if that helps, but that should be more visual, more able to visualize that. So write the related equation, just change the inequality for an equal sign, and then graph accordingly. What form do you have? What is your expectation? Find a point and a slope, or 2 points, and graph the line. But before you graph it, you do need to make note, is your line going to be dashed or solid? For this first one?
Solid.
Solid line, right. Oops. Can you turn that down? Because it doesn't go through the origin, I'm going to mark my test point, and I'm just going to use the origin, because it's the easiest one to use since it doesn't go through it. Question mark. So is 0, 0 a good solution? Does it make a true statement or a false statement? False. 0 is not less than -3. Therefore, that origin is on the false side. That means the other side is true. Questions? Problems? Cover-up gave me 2 nice clean points for this, but it doesn't hurt to check my work with the slope. And my slope is negative a over b. I've got a positive here. Therefore, I'm going to have a negative slope. A over b is 2 over 5, and so that negative a over b makes that negative 2 over 5. So I'm expecting a downward line that's kind of shallow. Yep, and that gave me that. Oh, but before I move on, before I fill in the dots there, this is going to be dashed. Because it is greater than, there's no or equal to. So this is the correct boundary line, but it is not included in the solution of the inequality. It's just the fence, the edge of the solution. And it doesn't go through the origin, so I'll mark that as my test point and see how that works. 2 times 0 plus 5 times 0. Is that greater than negative 10? Is 0 greater than negative 10? True. That is true. Therefore, that test point is on the true side. So you see, this mostly comes back to basic graphing skills. That's where the work is putting that boundary line on the graph. But that boundary line might be solid or it might be dashed, so you have to know which one it is, and then know which side to shade. Based on intuition backed up with a test point. Any questions on those, on the diagonal ones? I think you'll find horizontal and vertical ones even more straightforward. They don't really require a test point. They're more straightforward to graph. Not a lot of math, you just have to know the nature of the line. Can I slide this up? Does anybody have any still questions or problems with this? Okay. So here we're going to graph y equals 2. And we're going to make it dashed. Okay. So I decide what I'm graphing, the equation I'm graphing, and whether it's going to be dashed or solid. Because it's a horizontal line, I don't need any other information than that. Just where it crosses the y-axis. And dashed. Now, a test point shouldn't be needed. This is basically saying we don't care about x. X is not relevant with this horizontal line. X, it's just everything there. But the y's, any y you have that's going to be a good solution, has to be a y that's less than 2. So do I shade above or below? Below. Because all of these y values on the y-axis are less than 2. Sorry?
Wouldn't it be a solid line since it's included?
It's not, though. See how it's just less than?
Yeah.
Right,
yeah.
Yeah. Now this one, will this be solid or dashed?
That will be solid.
That'll be solid. Am I ready to graph it?
Yeah.
Where do I put my point?
You can move over the
Yeah,
side.
you have to, right? So minus 7 on both sides. So you're actually graphing x equals negative 6. Because this is x is greater than or equal to negative 6. Solid or dash, sorry, I said that was solid. Yeah. X equals negative 6. You've got that vertical line right there. And with a vertical line, we know there's all the y's are included, whatever. But we're being told that x must be greater than or equal to negative 6. So we'll be shading to the left or the right?
Right.
To the right. For all, that's going to cover everything on the x-axis that is greater than, and including in this case, negative 6. Questions? The first homework that's posted covers everything we did today. We've finished this. On Tuesday, we're going to be doing 2.10. That homework is posted as well. This, as you've seen, is mostly review, okay? Which just to understand of what the answer means and how to write it. So get ahead of this right away, and if at all possible, go ahead and read ahead. Look ahead at 2.10. That's going to be new material. Not review material, but new material on Tuesday. So sort of reading ahead and trying some of the homework is a good idea, because this next week's going to move really fast. Last week of classes. Okay. And I'll be down in the lab in 10 minutes.
For the final,
yes,
we can come in either on Tuesday or Thursday, or
I'm trying to arrange it so everybody tests on Thursday so that I can use Tuesday as a review day. I'm not sure if that's going to work out. It depends on if everyone in my morning class can test on Thursday, and they may have other conflicts with other finals. So I won't be able to announce that for a few more days.
Okay.
Okay.
Yeah.
Do you have another conflict for Thursday?
Yeah.
Okay.
Yeah.
Okay.
Yeah, that's why I was asking.
Okay.
But I mean, you said that we could do that thing that, like, you said if you need to or something.
Yes. So if you need to, what I need you to do is send me an email, just so I have it in writing. Otherwise, I'm going to forget. Okay. So if you have a conflict with Thursday, if it turns out that those students are testing on Tuesday, you can come in Tuesday morning.
Okay.
That's fine.
Yeah, the Tuesday's perfect.
Okay.
Yeah.
If for some reason I am doing a review session then instead, then what I'll do is I'll send you to the testing center.
Okay.
Okay.
Yeah.
So send me an email in writing so I see what your conflict is, and we'll arrange one way or the other.
Thank you.
Uh huh.
Have a good one.
Yes, you too.